normally you just assume that it could get plugged in wrong.
Yeah. Well, the fact that mine are going to be flying leads, it's entirely possible that I could get them wrong. So putting the diode on the input side makes all the sense in the world. The stripe on the diode indicates the output, right?
It's the cathode. There's no input and output. That's not how you learn diodes properly.
Okay.
The anode and the cathode. The way you have it drawn on your paper, the anode is on the left-hand side. Put an A on there and K on the other side. The cathode is spelled with a K. Not the way we spell it in English, but that's the symbol is a K. It's A and K. That's how it's measured. Because C means capacitor, so we don't do it like that.
Oh, okay, that makes sense. The concern I was talking about in the last video about connecting the batteries and the current moving from high batteries to low batteries and potentially being a lot of amperage, because the voltage difference isn't huge, I don't expect it to be a lot. I don't think it's going to be that big of an issue. But because it's my first time, I want to be safe. One of the things I've been thinking about is, I wish I had 6 phones, because then I could connect to each of the BMS and have them sitting side by side. And while I was thinking about that, I kind of suddenly had a realization and needed to slap myself in the head. That's what I bought these for. They'll show me the amperage, the voltage, and everything live, and I've got one of these for each of the batteries. So instead of my next step being to do the long run to connect the bus bar and start to connect the batteries, I think the next thing I'm going to do is build the rest of the buck converters. You saw in the 2 videos ago when I actually made the buck converter, but that was just really janky, just proof of concept. I'm going to try to come up with a better design. Full disclosure, when I say I mean I'm going to be bugging my friend who actually knows a lot more about this stuff. One that's going to allow me to put a plug onto the wires for the screen, have a header that plug can plug into, and add a protection diode. This is important because what I plan to do is have these wires wired into the circuit board and then going to ring terminals for the input where these will plug into the battery main pack positive and negative. The diode, what it'll do is if for some reason I took the positive and plugged it into the negative of the battery and vice versa, I wouldn't blow up the buck converter because the diode would prevent the electricity from flowing in the wrong direction. So one of the first things I'm realizing after getting off the phone with Andrew is these little proto board circuit boards I bought, probably a little bit too small. I thought originally they were going to be too big. Kind of wish I'd got the bigger ones. But anyways, this is what I have, and I need to figure out a way to connect everything. I think what I'm going to do is draw out this grid pattern on paper and try to figure out how I'm going to connect things, where I'm going to place things before I start soldering. Kind of wish I had a setup like Big Clive where he has that straight top-down view of the desk. I should probably look into getting something like that. Alright, that is what I have to work with. You have the pins that are designed so that this thing is soldered on laying flat. If I lay this flat the way it was designed to, and I put it so that the board is backing it, that eats up a lot of real estate. If I go like that, it takes up a lot less space. I don't think that's how it's supposed to be installed, but for my purposes, I think that might do the job. That would leave me a lot more open pins. And that feels fairly rigid. If I decide to keep these BMSs and screens when I go to the boat, I can always take another crack at this. Somebody very kindly offered to make a printed circuit board, and my friend also could probably make me one. So if I decide that these are going to make it to the boat, I'm going to redo these. So with that in mind, I am now designing these for relatively short-term use. Because of the size of the package, it's going to foul the rows on either side. So if I offset it to one side, then it's covering bus bars, which I can't use anyway. And that would put it here, and that would block. I could still access this one, and this one. This is obviously not a proper circuit diagram. This is just a layout plan, I guess. That is the input, output, and ground. Now, I need to mount a couple of capacitors. The capacitor has to span the, where's the blue? The blue is the negative. Can I fit these into that tiny little space? Oh, that's ugly as sin. I'm not gonna do that. I think this is just gonna be where I pick up wires. If I do that, I need to put the connector for the output. Do I wanna put it down there? Do I wanna put it up here? If I do this, does this block the next row down? Yes, it does. That is the output. Should the ground be on one side or the other, or does it matter? I wish I had a polarized connector I could look at. Oh, maybe I do. What is this doing? This puts the positive on the left. I have to remember this is the upside down view. So as I solder it, I want the outside to be my positive. And this is going to be, I know I'm putting negative, I know it's technically ground. These pins become accessible for the input, or for the output. Now, Andrew was talking about making a U shape for connecting my stranded wire. So I'm gonna have an input and an output. I wonder if I can do them down here, or should I do them across here? Where would it make more sense to put the capacitors? I need to put the capacitors somewhere. So I have to have a capacitor on the output that spans the output. So if that's the case, I can put that below. The blue stripe is the negative, just going to connect to here. So if I run from here to here and positive to positive, and then I can jump from the positive to here. Actually, if I'm going to do that, why don't I put this one? Am I confident enough to start soldering things? No, I'm not. If I put that there, the output comes to here, my capacitor here. That can't be used and that can't be used. The bottom ones can be used. Oh, actually, if that's the case, I should move this down to the bottom. That way I have my wires going between here. I am not good at art, but that's okay. This is going to be negative and positive of the capacitor. No, I got that drawing wrong. Oops, by pencil. So then this would connect to here. This would connect to here. So that's going to be a wire. That's going to be a wire. And then the output has to go to here as well. This negative has to go to... The negatives are completely common across the board, aren't they? Yes, they are. Why don't I use one of the buses as my negative? I have no idea if I'm going to put this in the video because I don't know if it's going to be interesting. Whatever. That's later Maddie's problem. So if I treat this as a ground bus, that should simplify a lot of the soldering. So if I do that, then I jump this to ground here. This capacitor ground can go to here, and this ground can go to here. I don't want to try to jam two wires into the same hole. So if I use the rail beside, damn it, I hit the maximum record time again. I don't know where it cut off. But what I've done here is I've made a little hoop of solid wire, and that will be something that I can loop this around. So this will be soldered into place, and then that'll get looped around that and then pinched and soldered, and that'll give me one anchored flying lead, and I need to do the same thing on the other one. So let's actually make another one. I can't see on the viewfinder if that's coming across, but there's two hoops that I will use to anchor my stranded wire. I'll do the same thing where the outside is the positive of the output. The outside will be the input, the positive of the input. So that flipped over means that these two are going to be bonded by the hoop, and these two are going to be bonded by the hoop. My poor drawing. So positive and negative. I did two positives. Positive and negative of the input. Okay, so if I know I've got that, then I need to find a home for the other capacitor. And this capacitor, it's same thing. I'm going, actually, why don't I put the capacitors right on the ground rail? Oh, that's part of the reason why. It wouldn't leave me anywhere to connect that flying lead to. Okay, if these had 4 instead of 3 in a row, that would have been so lovely. So if that's going to be the negative, that can get bridged straight to that bus. The positive, well, now I've got 4 pins to go for. So I can do that. Oh, no, I can't. I need to put a diode in here. Actually, can I do that jump with the diode? Hi from the boat. This is Editing Maddie. What I'm about to do is a mistake. You'll see more later in the video, but if you happen to be copying along, which you probably shouldn't be doing anyway, because this is me learning, but if you happen to be, don't put the diode where I'm about to put it. Would that make sense? Where am I going to put the diode? It's shown here as being before the capacitor. Does it matter? That gets plugged into positive. So the cathode goes to the input pin. It's going to be there, there. So I'm just jumping the bus is what I'm jumping. So that puts the protection diode from here. So this is basically going to go out, down, like that. And now I need to pick up from here, somewhere I need to put the capacitor. So I put that in there. So capacitor, space, and then I'm doing a capacitor here. That is the worst circle I've driven. That is the worst circle I've drawn since kindergarten. Same thing, this is going to be a positive, that's going to be the negative. This one, the negative is going to jump up to here, and the positive here has to connect to here. So that can do that. And if I've done this right, then these here will go off to my ring terminals, not drawn to scale. I hope this makes some semblance of sense. Let's see if I can summarize what I'm doing here. So this is mirror of this. So that's it like this. Mind me as I talk about this, remember that everything is mirrored. Buck converter in is buck converter in, ground, ground, out, out. So let's look at the in first by itself. I have the flying lead that is going to connect to the main pack positive. Main pack positive goes in through this hoop, that'll get soldered on, and that makes these two rows positive. Goes through a protection diode into the buck converter and comes over to my first capacitor, which then goes to ground. That's the input side. The output side, I bridge over to the run beside, and I have one flying lead goes to this pin. To the outside pin. So one flying lead goes to the outside pin, and the other flying lead goes to the other capacitor, or to the capacitor positive side. The negative goes to the ground, no connection. This capacitor goes to ground. Yeah, I think this is going to work. Okay. Now, this is where the helping hands come in. These are very small and cheap and old helping hands. Let's see if I have better luck soldering today than I did last time. Ooh, that was a good one. I mean, by my standards. I'm not confident that's the best connection, but I don't want to keep putting more heat into it. Ow! There's plenty of heat into it. Come on, flow onto the pad, you bastard. There, that flowed onto the pad. I'm trying to get the flat on the trace so that the heat gets into the trace. That seemed to have worked really well. I mean, it's a horrible joint, but it flowed nicely. No, Kepler, don't play with the thermometers, please. Come on, buddy. Those aren't toys. Basically, what I'm trying to do is connect all of the components, and then I'll run the bridge wires, whatever you call them. See, times like this, it just won't melt. I don't get it. I can feel the heat coming off of it. And that worked well. Well, I'll figure it out in time. My friend builds really complex circuit boards damn near in his sleep. He makes it look so easy. What I'm trying to do now, if it's right or not, is if I put a bit of melted solder on the tip and then use that to touch it, it seems to transfer the heat better. I can't believe that actually worked. Okay, putting a dollop on the end seems to make it so much easier to flow. So now what I need to do is make jumpers. Is that the right size? I think that's close enough. I think I'm actually starting to get the hang of this a little bit, crudely. I'd be very curious to see how this looks compared to the 6th one I make. This is tricky work. Especially since COVID kind of messed up my eyeballs. With the amount of solder on these pads, with the amount of solder on these pads, I don't think I have to worry about the current carrying capacity of them. I'll pull back in case that makes for better footage. I really don't know what's going to work. I have not done this type of video before. That connects the ground to the bus. Now I need to get another short one. 2 capacitors have to be pulled to ground. As with everything, the first ones are the slowest, so you're figuring everything out. I expect this will speed up. Can I do this without anything falling apart? Remember why I didn't use these. They were kind of cheap. That's completely collapsed. I forgot how much these sucked. I didn't pay much for them. I was very poor at the time. You know what? I think one arm is fine anyway. Oh my god, don't tease me into thinking I'm actually figuring this out. Okay, I just had a whole bunch of ones in a row that didn't suck. That went frighteningly well. How long should I make these? Whatever length that is. Positive was the outside. Yep, it's connected. All right, I'm gonna get a little bit of tiny shrink tubing. You know, I could have just paid $30 each and built buck converters. I didn't have to do any of this. I thought, it'd be a lot cheaper. I'll just buy the $8 chip. Well, I'm learning. I'm learning how to solder. That's a good side effect of this. That's the real value of these. That is a completed buck converter. Not sanity checked, it could be flawed. That's tomorrow's concerns. Last thing I want to do is, while this is still hot, is to crimp on, where did that go? The connector which pushes into the female. Apparently when you delete files off SD card in Mac, it doesn't actually take them off the SD card. I didn't realize that because I don't usually delete my SD cards on my Mac. And I ran out of SD card space towards the end of the build yesterday. One of the things I want to do is be able to put all 6 of the screens side by side by side by side so that when I start to connect the batteries, so that I can see amperage transfer in real time. These leads are not long enough. I think this one's going to be okay for one of the 2 center batteries, but for the other 5, I'm going to make much longer wires. So let's see if I got this right. So I should have a diode from here to here. So let me go into diode test. This is the high voltage input going through a diode to the input of the buck converter. And I am indeed seeing a diode. And I should know that's working because if I flip it around, it shouldn't work. Yep, and it doesn't work. So that's telling me that the power is only allowed to go this way. It's not allowed to go this way. That's the positive side. Okay, so that is good. And this should test here. Yes, so my flying lead is good. So the positive side of the input is good. Let's do the positive side of the output. So I should see a connection to here. I do, and I do. And to the positive side of the capacitor. And I do. Now, the grounds should connect to a whole lot of things. That's the bus. And it does. So this should connect to the flying lead. It does. It should connect to the negative of both capacitors. That's the input capacitor and the output capacitor. And to the negative lead. I never connected that. All right, I missed one. That's exactly why I do the test. So what's missing right now is the connection from the negative pin to the ground bus. Easy fix. Pretty? Nope. Should it work? Well, hopefully. Now let's see if that ground is connected. I mean, obviously I just did it, so it should be. So we're back to the ground, and that's connected. That all looks good. I think I am ready to turn this on and see if it works. I need to go get the power supply. My desk is very, very quickly running low on space. Turn this over so I can check the voltage on the output pins when I connect it. And also, if it blows up, this is the side the smoke's going to come out of, which is better for YouTube. I'm going to weigh this down so it has nowhere to go, so it doesn't short out against anything. Okay, so the output is ramped up to 36.5. I'm very quickly developing a new appreciation for people like Big Clive and how they show everything on their video. Let's turn this on and see if nothing smokes. Nothing smoked. Check the voltage. 11.99. This one works. I am going to build exactly what you just saw 5 more times. The only difference is the flying leads are going to be longer. There's no reason for that to be on camera. It's a buck converter. I suspect most people would be far more sensible than me if you needed a buck converter and you're just going to buy a complete one. So I'm going to turn off the camera and bang these out. Hello. So I'm not going to finish tonight, but I wanted to turn the camera back on because I've gotten through these 4 buck converters. I'm doing the last line right now. I have noticed in just the little time I have gone from, where's the first one? In the time since the video when I built this one, to the start of this video when I built this one, to the ones I'm making here, would I say that I've learned how to solder? No. Would I say that I've gotten a heck of a lot better than when I was starting? Also no, but I've gotten better. I actually can pretty reliably now warm up a pad. Well, I tin the pad. There's other people who do much better videos on how to solder. I'm not going to try to teach because I'm still learning, but I've gotten to the point now where I can tin the tip, apply it, and flow it pretty regularly. I was very frustrated when I was trying to make the first one. I mean, you guys saw that on the video. I couldn't get the damn solder to flow. And when I was making the second one, it was getting a bit easier, but it was still quite a struggle. Just this little project. Was this financially worth it? Should I have just bought finished buck converters? If you're asking from a financial perspective, absolutely. The amount of hours I've poured into this, the amount of work I've put into this, and honestly, after I've bought all the parts, the amount of money I've spent on all of this. Financially dumb. Am I glad I did it though? I suck at this still, but I suck way less than I did at the beginning, and just over relatively a bit of work. If you have any interest in learning how to solder, a little project like this, totally recommend it. Okay, my back is killing me. I'm gonna do a little bit more soldering. I'm not gonna test anything tonight. Next time you see me, I will be in a wardrobe change because it will be tomorrow, because I'm about to call it a night. This is really fun. You should try it. Definitely. Okay, back in a minute. Next day, pick up where we left off. I have got all of them made, and now I need to verify I don't have any shorts, I didn't make any mistakes, and then connect them to the power supply and make sure that I'm getting 12 volts out. And then I should be able to hook up all of the screens. And then finally, connect the main system. That's not happening tonight. Tonight, I just want to make sure that all of my buck converters are working properly. All right, let's see if we get 12 volts on the output or if we get smoke. 12 volts, sweet. One is done. Applying power, no smoke, checking voltage. We have 12 volts, that's too good. That's the integer 2 are good, not too many are good. I'm not running these for long or running any amperage through them, so there's still a chance that even the ones that pass could still fail. 12 volt, that's 3 that are good. Ready to test number 4. No sparks. 12 volts. 4 are good. 12 volts. We are good. We are good, we are good, we are good. So now I know, somewhat miraculously, all 6 of my buck converters seem to be working just fine. Obviously, I haven't put them under any real load. Not that the screens are going to put them any real load, but the point is, so far so good. So the last thing I need to do is put connectors on all of the cables. I'm not going to make you watch that. There's no risk of something blowing up. I don't see the reason to keep the camera going, so I'll be right back. Got everything built. Got the screens ready. Got all the screens labeled. It occurred to me that I don't remember which is up and which is down. So I may have labeled these all upside down. If I did, y'all can laugh. I'll laugh too, and then be annoyed and have to change the stickers. But anyways, all of the JKBMS crazy cables have been terminated. It's time to hook this all up. So I've been trying to think where I am going to connect the buck converters. And why was I holding that? I've been trying to think about where I'm going to connect the buck converters. I want to have the screen go off if the BMS is off. So I think what I'm going to do is take the negative and connect it down here where, you can't probably see what I'm doing here, but where the BMS connects to the Anderson lead, that's where I'm going to put the negative lead. The positive I'll put on the main pack positive. I was thinking of putting it on the far side of the fuse so that it would shut off if the fuse blew, but well, I mean, maybe I should still do that. You know what, I think it'll be okay because if I put it up here and somehow it dead shorts to ground, this is so little wire, it'll just become its own fusible link and just vaporize and cut the circuit. It'll be spectacular, but I don't think it would be dangerous. I know somebody's typing right now, yes, it would be, and you're probably not wrong. And for the record, I am very happy that I made these, but if I end up taking the JKBMSs onto the boat, these buck converters will not be coming with me. And I know you guys can't really see what I'm doing here, I'm sorry, but I'll show you when I'm done. Having a YouTube channel makes mistakes a lot less painful because you can think to yourself, well, it makes for good video, as opposed to suffering in silence. I guess it's not suffering in silence, but suffering in solitude. There we go. So I'm probably going to do this type of a setup. I made those leads definitely longer than I needed to be. Okay, that is not going in no matter what. Yes, I think solder flowed into... I'll be right back. I need to fix this mistake. After I turned off the camera, I decided to check the others. I ended up finding 3 that I had let solder run down the pin. This is going to be such a mess on the floor trying to get these all into close proximity. I definitely made these longer than I needed to. However, I will keep saying the same thing. You don't know what's going to work until you try. 2 completely done. Battery C is done. Oh, what a wonderfully glorious mess this is. Oh, my poor back. I know it hasn't been a lot on video, but I've been hunched over my desk, soldering and putting parts together for a fair bit of time now. Looking forward to the day when all of this is self-contained in a box, and all we see is a wall of screens. It's going to be very pretty. That is battery E. So all we have left is battery F. Hey Picasso, you curious what I'm doing, or are you just wondering why it's not related to your food? Whoa. I don't know if that came off on camera, but Kepler just jumped tatters and spooked Picasso. Oh, this is one of the nylocks, which I didn't mention on video last time. But yes, I'm testing out some nylock washers. Hey Picasso, stay away, okay buddy? That's all of it. Let me bring you in and show you this kind of insane little setup we've got here. So on each battery, I've got the buck converter 48 volt input line going to there. I've got my cats going off in the background. And the buck converter's ground is connected to the output side of the BMS. So the buck converter will not be powered on unless the BMS is turned on. Now, I don't have any way to turn the buck converter itself on and off. In hindsight, I should probably have put a switch or something, but hindsight's 2020. God, this is such a mess. Wow, this is temporary. Whoa, something just blew up.